3.8. Oh, I got more stuff here. Let's see.
So question, you said it's gonna be wrong if we put the y-intercept as just a number, if we put like b equals -2.
Alright, come at me again.
So like, I know you said if we put the y-intercept and just like -2 is the answer, then we'd be wrong.
Totally.
But what if we had put like it in the formula, y equals mx plus b, which means self-explanatory that the x is u.
That phrase, self-explanatory? I love it. Where's your steps of work? It's self-explanatory. No.
Man, Jeff.
No. You're the self that must be explaining to me. No.
We're not building a rocket here.
Huh? Okay, good. No, we're not building a rocket here. I love it. But if you ever want to be able to build a rocket, you better start showing your shit now, so that I can correct you. Because sometimes the reason I got to see work, there's so many reasons. But one of the main ones is you might get the right answer, but have done things completely wrong, and I have missed a chance to show you why it's wrong. You got lucky on that one day. This is just one example of why I need to see work. Right? I mean, I could do something with work. I can't do anything with just the wrong answer staring me, or a right answer staring me in the face. I can't do anything with that. Yeah, show me your work. I could do something. So sorry. Well, I was in the middle of doing something later. Yes, sorry. So 3.8. Yeah.
3.8, number 22.
Oh, okay. This is a really good problem. Let's put it over here. I love this problem. That should be a cautionary tale when I say that. Let's see there. There it goes. All right, let's see. This one here, right?
Yeah.
All right. Let's look at 22, because I don't want to do your homework for you. Now help me. All right, let me do it over here. Somebody please help me. If I had a function, f of x equals 2x plus 1. Oops, unfreeze that shit. And I put a, what do I get when I put a 1 in? 3. What is this? What can you tell me? Can you tell me, hey, what does this mean?
F times 1 equals 3.
No. Okay, I'm really happy I said this.
The input.
This is not times. This is not times. Like if I say this is not square root times 9, right? This is square root of 9. So this is f of 1. When I put a 1 in,
The output is 3.
I get a 3 out. Now take one more step with that. Marry it to graphing. What could I graph right now for this function? What point would it go through?
1, 3.
So I could plot the point 1. My God, this is gross, but oh, I could plot the point 1, 3. If you give me this in your homework here, no. Right? Now watch. So if I did not tell you what the function was and I said, what's f of 1? How could I know it's 3? Because that's where the point was put. Right? So the work's already been done. What's the graph? What is the whole idea behind a graph? Why do I graph anything? Because it's a visual representation of all the answers. So when they give me this graph, they're giving me all the freaking answers. So I love when people are like, they don't tell me what f is. And I'm like, you should be really happy they don't. You got a lot less work to do. So for number 22, what must f of 1 have been? Look at the graph. Where did they put the point for an input of 1? Is there a point right here? Is there? Where are the points at? Where's the flat? Where? There it is. So at 1, what must the output have been? Where do they put the point? Negative 1. There you go. So what's f of 1? Negative 1. I don't have to do the work because they already did. And then they plotted the graph for me. They're like, here's all the answers between negative 4 and 3. What's the function? Why do you care? You got all the answers. So that's how you do f of 1 for all of these, right? You just look at 1 and see where they put the point. That must have been the answer because that's why they put a point there. We're connecting all these things together now. What about the domain? What letter does the domain relate to? What? X. Remember, how do you get the domain? You start walking along the x-axis. What's the smallest x and what's the biggest x that has an output? Negative 4 has an output. Nothing below that does. And I see it all the way up until 3. And these are both closed circles. So the domain would be bracket negative 4 comma 3. Because which x values have an output? All of them between negative 4 and 3 do. Yes?
So if those were open circles,
Then you would put parentheses, because you couldn't include negative 4 and 3, because they don't actually go anywhere. There's open circles. I like it. So, does 3 go somewhere? Yes. 3 goes in. If this is an open circle, does 3 go somewhere? No. It doesn't go anywhere. Nothing shaded in for 3, poor little 3. So you would put a parenthesis on it if it was an open circle. What about, oh, go ahead.
because it doesn't include the 3.
Because then 3 would not have an output.
Right.
And so you could include 3 in the values that have outputs. That's what domain means. Domain is all the x values that actually have outputs. What's the range?
All the y values?
All the outputs, all the y values. So what's the lowest y value? Negative 2. And then when do I lose it? 5. So it would be bracket negative 2 to 5 for the range. Domain x values. All the x's that have an output. Range y values. All the y's that are outputs. So that's part B and D. Now C is sort of like A. What x value leads to an output of 2? So look at part A, I looked at 1 and I saw where it went to. So part A is like, here's the x, what's the y piece that goes with the point? This is the other way around. I want the output to be 2. Yeah, so I say what point has a y value of 2 on the line? Negative 3, 2. So negative 3 must be the x value that leads to an output of 2.
So would we write negative 3 or we put f of negative 3?
You would put, so the answer to the question about x values, so you say x equal negative 3.
Okay.
That's the value that leads to an output of 2. So what value leads to an output of 5?
Negative 4.
Negative 4 leads to an output of 5. I like it. Which x value, what is f of 3? Negative 2. I love it. Yes. Okay. Is that cool? Yeah, that's how you do all those. There's 4 parts for every single one of those. I like it. I like it. Anything else from homework stuff for that problem? Yeah.
What about 85?
Oh, 85 is asking you find the domain of the, okay. So, the kind of functions that will have a problem with their domain, for example, does this function have a problem with its domain? And how do you interpret what I'm asking? Domain is x values. Problem with means an x value I can't use. Does this function have an x value I can't use? Yes. What x value can I not use? 1. Why not? Because it makes it 0 on the bottom, which is undefined. Right? But what about this function? Does this function have a problem? No. Is there a bottom to this?
Yes.
Is there a bottom? Sort of. It's over 1. So can the bottom ever be 0? No. There's no variable on the bottom. So any, well, we're going to eventually call it polynomials, but right now any line like x plus 2, 2x minus 1, what's their domain going to be? All real numbers. There's no value of x that's going to freak it out. How can I tell? When I graph it, it goes forever in both directions. There you go. It doesn't leave any x values out. So in the future, we're going to see another possibility would be something like, square roots have problems, right? Anybody remember a square root can't have what kind of number inside?
Odd.
It can handle odd numbers. Square root of 9 is 3. Negative numbers, it can't do. So this guy's domain is going to be all values that are at least 0. This one would be x greater equal to 0. So there are certain functions whose domain is not all real numbers because they have requirements. The first one, the bottom can't be 0. This one, the inside can't be negative. But if I just have a line, what number can I double and subtract 1? Any freaking number. It doesn't matter. I can do that. Like maybe? No? Okay. Yes? Yes? No? Okay. One of those. Anything else from homework stuff? I feel like I skipped somebody over there. Okay, so we're about to get into is the math behind. Let me do it up here. Let's just stay here. The math behind if here's the United States. You ready to laugh? Here's the United States. Okay, there's Florida down there. Some country decides to throw a missile at us. Let's just heave it. Hi. Right? And what would we like to do about that, do you think?
Shoot another missile at it.
To do what?
Blow them up in the air.
To blow that freaking... So I want to be able to shoot a missile that has a certain trajectory so that these two curves will meet. So in physical reality, I want to blow the shit up out of that missile before it blows the shit up out of something in my country, right? You guys with me?
Yes.
All right. So this is the whole idea. Now we're going to have to take it down from missiles and world annihilation all the way down to just straight up graph lines and look. But I'm looking for where the lines meet. So if I knew, so this is going to lead to the possibility, if I know the equation of motion of one thing, I can set the equation of motion with this other thing so they will meet. So we got to start with, well, how can I tell where two things meet? Right? Okay, I like it. And there's multiple ways. There's a graphical method, and thank God there's an algebraic method. Because if the answer is 1.1724446, comma 3, I ain't going to get that by hand. Especially not me. You see my graphs? It's not going to happen. So, what we're doing is systems of equations. Oh, baby. So we call it a system when I have more than one thing. So when I have more than one equation, in this case, one equation was for the enemy missile and one equation was for my missile. So that would be a system of equations of motion of rockets or missiles. So help me out. We just talked about this earlier today. Why do I graph? What's the most basic reason why I graph a function? Why I graph something? Say again?
To have a visual representation of it?
Sure, visual representation of what? All of the points, all the answers to that equation, right? If I ask you, so for example, if I ask you to list, please list all the answers to this. Right? We can list a few, right? And then we kind of get bored. Right? Some of you guys are like, I had to beat, I was bored. Give me an answer to this.
2 and 2.
Yeah, so 2, 2. Give me another one.
21.
1, 3. 3, 1, I love it. 4, 0, 0, 4, blah, blah, blah. How long does that list go?
Forever.
Forever. Because what about 1.7246693429771, comma, whatever the shit else makes 4, right? Every single number you can imagine will have a companion to add up to be 4. Does that make sense? So what's the quickest way to answer that question? What's the answer to this? Is to give somebody a graph. Because then they can just follow the line and see whatever specific answer they want. You guys with me? I mean, that's the most basic reason why we graph any damn thing, is it's the quickest way to show all the answers. That should kind of kick ass. And because they're supposed to both add to 4, that's why it's such a rigid relationship between the two. When I start throwing squares and shit in there, it's still going to be a relationship, but it's going to be kind of curvy. Right? You guys semi with me? But when everything is to the first power, it ends up being just a straight line. I love it. Okay. So what if I came in and I said, and I know, not only do I know x plus y is 4, I also know that x minus y is 2. So this should kind of make sense. I always look at this as like it's one of those dumb CSI shows where I'm trying to figure out who killed this guy. So at first, all I know is there's a dead guy. How many things do I not know? A lot. So the more things I don't know, the longer it is and the more information I need to figure it out. So here in math, we can be very specific. How many things are there that I don't know in that equation? Either one of those. Yeah, 2 things. So all I need then is 2 pieces of information to figure it out. Either one of those by themselves has an infinite number of answers. Can anybody tell me from the list we made, is there a point that matches the other dude too? Is there anything that where the x piece minus the y piece is 2?
Yes.
Which one? 3, 1. That is the only point that works in that dude and that dude. That would be sort of like the point where the two, that's the point where they meet and they blow each other up. Right? And we want that point. We can kind of control where the point is so it's high enough up so it doesn't like mess anybody's day up.
Vertices, right?
Huh?
Vertices of parabola.
Not quite there yet.
Okay.
Not quite there. We're not going to bring curvy dudes in here because then that gets a little freaky. There could be multiple points of where it meets, right? So let's make everything straight. All right, so let's do this. Let's plot both of these just so I can show you visually. We already know what the answer is supposed to be. So let me see if I can borrow. Yeah, here we go. Here, screw whatever they wanted this to be. Let's plot both of these lines on this. So somebody help me out. How would I plot this quickly? Well, I've already got points here, don't I? But if I didn't have points already, what would I do to plot this quickly? Yeah. Solve for y. What's the y-intercept? 0, 4. 0, 4. And what's the slope? -1. So I go down 1, over 1. I'm just going to go down 1, over 1 a few more times than we normally would. And then I connect those up. There we go. Alright, so that is x plus y equals 4. So everybody with me? All I'm doing is graphing this dude. On top of that, I'm going to graph this dude. So just to cut to the chase, if I solve for y, I'll get x minus 2. What's the y-intercept here? 0, -2. And what's the slope on this guy? 1 over 1. So I go up 1, over 1. Up 1, over 1. Up 1, hey, I got a match. Where'd they meet? 3, 1. Freaking 3, 1, which of course we already knew. Right? Because this is a very simple example. Not every example would be that easy. But that's really cool. The visual of the answer to a system of equations is just where the two meet. Because each line, every point this line goes through is an answer to its equation. Every point this line goes through is an answer to its equation. So where's the point that works in both? Well, it's got to be the one that they both go through. That makes almost too much sense to believe. Hopefully, right? If they all go through all the answers for their equations, which point works in both? Where they meet. Actually, I think we did. There, one solution. We ended up doing an example that had one solution. How could it have no solution? If the answer is where they meet, what kind of lines would that have to be? Parallel. So any lines that are parallel will have no solution. That would suck. Here comes the missile. Go shoot our guy. Oh, shit. All right, that's bad. Now, here's the freaky ass one. What's the last situation there? This is page 47, by the way. Infinitely many. What the hell would that mean?
They're on top.
Yes. If the answer is where the lines meet, the only way to have infinitely many solutions is for the lines to actually lie on top of each other. So this is a situation like, if there are two things I don't know, I should need two pieces of information to figure out an exact answer. So how in the world could I have infinitely many if I actually don't get separate pieces of information? So if I said I'm twice as old as you, which is completely possible. How old are you?
22.
Almost. I'm a little more than twice as old. So if I said, let's just pretend that you're a year old, right? So if I said I'm twice as old as he is, and then I said he's half as old as I am, have I just told you two pieces of information? Think about it. I'm twice as old as him, he's half as old as me. I've told you the same thing twice. I have. Think about it, right? Yes? Yes? Okay, I like it. If I said x plus y is 6, but y plus x is 6, that's the same stupid thing, right? Here I told you the same information. So that would lead to infinitely many solutions, because I still don't know shit. Right? So that would be, for example, this. Plot these for me on this graph. What you got, Jeff? X plus 2y equals 4. And 2x plus 4y equals 8. Well, this is a good example. This is a good review. I want you to graph both of those lines on that graph. Of course, the quickest way to do that, as we've said earlier, is to solve for y. So if you solve both of them for y, you should be getting the same result, right? You should be getting negative 1/2 x plus 2. So to plot both lines is kind of silly. So there's my y-intercept 0, 2. Go down 1 over 2. And then the other line would just be right on top of that. So if the answer is where they meet, infinitely many solutions is right, but we can be more precise. Where do they meet? What points do these two meet at? All the points that are on that line. That's the answer. All the points on the line. So sort of like we're right back to where we started. If I give you one equation, there's infinitely many answers. All the ones on the line. If I give you another equation that's actually just, do you see how that's just double that one? So I didn't even give you really a separate piece of information. You're still where you were before. You're like, thanks. If I'm trying to solve a murder, I'm like, well, Joe, he was down at the deli. All right, so it can't be Joe. And by the way, that guy Joe, he was down at the deli. I already know that. Thanks. So it still could be anybody except Joe. Thanks for the information. That's just what happened right there. Joe at the deli, Joe at the deli. Ah, shit, we don't know shit. Yes?
Did you simplify when you got here? Is that how you got it to be the same?
Yeah, exactly. You just reduce that. I love it. Big ass. Okay, okay. But this has limitations, obviously. If the answer is gross, like I said earlier, you're not going to get it graphically. But for right now, they're going to give me semi-decent answers. Go ahead and try to do this one. It's page 48. So you plot one line, and on top of that, you plot the other line. Just in case you know this, there's a method called substitution. There's a method called elimination. You are not allowed to use either one of those methods in this section because it's officially before we learn them. You do it on the side to check your work. Why not? So just when you do these problems, you want to take a few more slope steps than you normally would. Because otherwise, when we start to connect dots, we sort of curve. And we're going to be like, where the hell do these lines meet? So you want to give yourself more anchor points. This one's not that big of a deal, I don't think. Now this is really going to suck, because if you mess up this first step, solving for y, you don't have a chance, right? What do I know of the first two? Y-intercept is 0, -4, I like it. And from there I go up 2 over 1, up 2 over 1, up 2 over 1, over 1. And then break. Okay, sure. That's like a river straight, yes.
I have a question
Yeah.
about this. I don't know how I got the negative. Like, how do I get rid of that when you get to this part?
So you subtract 2x, and then you divide by -11. So then this should be -2x, right? It's subtracted.
Oh, okay.
Yeah. Now, real quick thing, how did I solve for that so quickly, besides I've been doing freaking math every day for so long? Whenever the thing I'm trying to solve for is negative, I add it over. So really, I just add the y over, subtract the 4, bam. Bam. Because dividing by -1 just leaves it open to, I don't care how good you are at math, you're going to make a mistake of that somewhere. So I just say, I'm just going to make that sucker positive to begin with. Or do it however it works. All right. So that's that one. That's line number 1. What about line number 2? What do you know about him? I love it. What do you know about him? 0, 2. And then I go down 4. 1, 2, 3, 4. Hey, I got the answer already. Sweet. Yeehaw. What's the answer? 1, -2. Dear God, if you don't put the answer down, you just stop here. I know it's going to be, someone's going to say it's self-evident, but no. You got to write that answer down so I know you know what the shit you're doing. I like it. How do you check this?
Plug it in.
Plug it in. You plug a 1 in, 2 minus 4 is -2. Plug a 1 in, -4 plus 2 is -2. Kick ass. It works in both. I like it. Do the second one. You probably should know the answer before you do anything, but still graph it. It's good practice for that. If you don't know the answer yet, don't worry. You're fine. Graph them. See what happens.
And then for the last one, why were we
Why couldn't you use division? What do you mean? To solve for y?
Oh, no, never mind, I got it. Yeah, I was confused.
before you even graph these, you should know what kind of lines these are.
Negative slopes.
How do their slopes compare?
This
They're
is
the same, and they're also offset, so they will be parallel lines. If their y-intercepts are also the same, then it's going to be one of those infinitely many solutions. They're actually laying on top of each other. This is separated. All right? So if I plot this first one, 0, -1, go down to bam, bam, over 1. So here's the first equation. And the second equation, 0, 2, down 2 over 1. There's the second equation. And supposedly they are parallel. Yeah. I love it. See, if I was in my class, I would say, Mr. Waller, please invest in a ruler. All right, yes, sir. Okay. The better you are at graphing things, the easier this section should be. You graph them and then you just step back and see where they meet. Do more steps with the slope. You will have to do a few to really believe me if you don't currently believe me. Let's see. Do I want to do that one? No. So the issues with this method would be if the answer was 1.719, comma 3.428. I'm nowhere near that precise to be able to get that. So we have to have an algebraic way. So this is the last thing we'll talk about today. But I want to show you this. This just kicks so much ass. I love this method. Almost as much as the next method, which is where we get to kill shit. This method is very subversive. This is kind of like Invasion of the Body Snatchers. Have you ever seen any of those Invasion of the Body Snatchers movies? Pod people, and they take your place when you're sleeping, you're dead, and they take your place, and there are you. Ah. So this is very much like, that first equation says x plus 3y is always negative 28. All right, there's an infinite number of points that work. Great. But the second equation tells me y is negative 5x. That's what y is. In this little universe, that's what y is. So I can rewrite the first equation using that information. So I can look at the first equation and rewrite it. The first equation is x plus 3y, but what's a better way to write y?
3 times negative 5.
Yeah, because y is negative 5x. So I write x plus 3y, but I replace y with negative 5x equals negative 28. Now, why is that a better equation then?
Because you only have one thing you don't know.
Beautiful. I only have one piece of information I don't know, and I can solve for that now. Go ahead and solve for x real quick. So this method, amazingly enough, is called substitution. I substituted for y, I put the expression in. Now here's the trick about this. Is everybody getting there? Not the trick, but here's what you gotta be careful about. We're so used to, of course, stopping there, but what's the answer? Just like we learned in the last section, what's the answer to a system of equations?
You have to find what?
Yeah, the point where they meet. So I'm not graphing these, but the graph is always in the background. I'm doing it algebraically, but the graph is saying it's the point where they meet. You only got one piece. How do I get the other piece?
You gotta put it in one.
Doesn't matter which equation I use, because they're both supposed to be the same. That's actually a way to check. You can plug it in both. But right now I'm going to plug 2 into which one? Yeah! Y is negative 5 times 2. That's solved for me already. So what do you get for y? Yeah, so I know x is 2. Therefore, I know y is negative 10. So what's the point? That's the answer? 2, negative 10. So I'm not going to take points off if you have x equals 2, y equals negative 10 separate. But you really should put them together as a point. Because that's the whole point, sorry. That this is where the graphs would meet if I did graph them. Let's do one more of those, and then we'll call it a day. Let's do, no, I don't want to do that one. Let's do number 3. Number 3's got something you got to be very careful about, isn't it? It's related to that minus in front of the y. So make sure everybody's on the right track. What variable do I know something exactly about? Y. I know y is,
Negative.
no.
4x minus
I know y is 4x plus 3. You guys see that? That one statement tells me what y is. It just says y is this. So I'm going to use that to rewrite the other one. Instead of y in the first one, I'm going to put what y is. Y is 4x plus 3. Please love that shit. So the second dude tells me, well, y is 4x plus 3. I know you guys are like, we still don't know what y is. But me being a math guy, I'm like, I know shit about y. It's 4x plus 3. That's fantastic. I can use that information anywhere else. Because that's just given to me as a truth. That's what y is. So here's where people make a mistake. So I'm going to use this information in this information. I'm going to rewrite this guy as 4x minus, I'm making a mistake, I've made a mistake. Yeah. 4x minus y. So minus, that's what y is. You can't just subtract a piece of y, you got to subtract the whole freaking y. And now here's where, I love you guys so much. You hate variables so much, but then you're constantly trying to save them when they are supposed to just die. Right? And why am I saying that here? Because what happens here?
negative 4x.
And what's 4x minus 4x?
0.
Yeah. Don't circle this shit. Now, what do you think that means? Second. It's not no solution, it's the complete opposite. Infinite number of solutions, these lines are actually the same. If you solve that first one for y, you get 4x plus 3. They are the same line. So algebraically, what will tell me that there are infinitely many solutions is if I end up with a true statement. If I end up with a false statement, that probably means that they are parallel. There's never a solution if they're parallel. So if this said negative 3 equals 4, no solution. They never meet. But if it's a true statement, they always freaking meet. They just always meet. They're always true. They always intersect. So next time we'll talk about the elimination method, and we'll talk about how to do this on the calculator to really check ourselves. Check yourself.